Hi everyone, this is Dr. Hamilton. You might have seen me around. If not, I'm sure you'll see me around again. Now, I have to tell you, I'm making this recording for you at my house, and I have two dogs and a cat, so you may hear, oh, look, there's a cat here now. We may get a few interruptions, but that's okay. What we're going to do today is read this piece that your teacher has given you together. So I'm going to read it to you, and while I'm reading it to you, oh, the cat just got rid of my picture. While I'm reading it to you, I want you to get out a highlighter, and I want you to highlight some of the vocabulary words as we're talking. So let's read this together. We're going to start right here underneath where it says reflect. Has anyone ever told you to sit still? You may do as you're told, but in truth, you can never really sit still. And that's because, as you probably have already heard, the Earth is constantly moving through space. But did you know that the ground beneath your feet is constantly moving too? However, we don't feel this constant movement. Why don't we feel it? The Earth's surface is divided into plates. Our planet is made up of several layers. The top layer is the crust. The center layer is the core. Between the crust and the core is a thick layer of partly molten rock called mantle. Earth's crust and the uppermost part of the mantle together make up a layer of solid rock called the lithosphere. The lithosphere is the cool, rigid outermost layer of Earth, and it's broken into large pieces called tectonic plates. Now let's stop there and go back and do some highlighting. I want you to highlight the words that are already bolded. You can see that I already highlighted the word lithosphere. I want you to highlight crust. This is the top layer of the Earth. Core. Here's the center layer of the Earth. We have some molten rock. Go ahead and highlight both of those. Maybe you remember hearing about that from when you studied rock, specifically igneous rock. Lithosphere, and then go ahead and highlight tectonic plates. The tectonic plates are, remember, the thick pieces of the Earth's crust. I'm going to move myself over here so we can talk about this. These tectonic plates contain different types of crust. The crust beneath the oceans is called oceanic crust, and this crust is denser than the crust that makes up the continents, which is called the continental crust. Let's take a minute to look at that picture over there. That picture here shows us a cutout of the inside of the Earth and also how thick these pieces are. So here's the lithosphere. Can you see that it's just this tiny, tiny piece here, the uppermost layer of the crust? And then you've got the mantle, which is all this piece here. That's the mantle. And then you have a liquid core and then a solid core. All right. Now, the tectonic plates contain different kinds of crusts. We already read that. The crust beneath the oceans is the denser crust. Okay, scientists have given names to these tectonic plates. The map below shows the current major tectonic plates. Many of these plates are named for the continents or oceans they support. Maps of ancient land and water patterns show how Earth's plates have moved great distances, collided, and spread apart. So you can see the plates are broken up, if you look here, a lot like different continents are named. And here's the major tectonic plates. The African plate here, the Antarctic plate here. Look at the North American plate is huge. And you see that the plates are also under the oceans. So it's not just land, but also under the oceans. All right, now, what is it that moves these tectonic plates? Well, that's convection currents. Convection currents move tectonic plates. Just below the lithosphere is a shallow layer of mantle called the asthenosphere. Here's another huge science word for you. The partially molten rock in the asthenosphere slowly flows due to a process called convection. Tectonic plates of the lithosphere float on top of the asthenosphere as they are less dense than the material of the asthenosphere. So think about an ice cube floating on water. The ice cube is less dense than water, so it floats around on top of the water. Convection is the process by which hot material rises and cooler material sinks. So maybe you've heard about this with air, how warm air rises and cold air sinks. That's the same is true with the mantle. The mantle is warmer near the core, and as it warms up, it rises, and then as it gets farther away from the core, it cools down and then sinks. So convection is that process where it's rising, cooling off, and falling, and warming up and rising and cooling off. Let's go back to here. Beneath Earth's surface, temperature increases with depth. Deep within the Earth, the soft material of the asthenosphere heats up and rises toward the crust. As the material gets close to the crust, it cools down. As it cools, it sinks back toward the core. Eventually, the sinking material heats up and rises again. This circular movement is called convection currents. And in this picture beneath me, you can see the arrows where you have this warm mantle rising. It's moving this way, and then, oh, now it's cooled off, so now it's starting to sink. And then it's happening here. It's sinking, and it's warming up, and then it rises again. And here's a plate right here. So you have this plate that's being pulled along right on top of that moving mantle. And some of this crust right here is sinking back down into the mantle where it will eventually melt. All right, so take out your highlighter again. I want you to highlight the words we've seen here so far. I'm going to move my face out of the way so we can do that. We have convection currents. That is what's moving the tectonic plates. And if we go down here, this is where we define convection currents, this circular movement of the mantle. And the asthenosphere is the shallow layer of mantle called the asthenosphere. And convection, when hot material rises and cooler material sinks. Okay, as you can see in the diagram up above me now, some convection currents in the asthenosphere flow in a clockwise direction, and some flow in a counterclockwise direction. As the asthenosphere flows, tectonic plates move with it in different directions. Scientists explain this process through the theory of plate tectonics. So here we have the convection currents pulling the plates with them as they move. Tectonic plates float on top of the asthenosphere as it flows. However, the asthenosphere is not actually a liquid. The asthenosphere is solid, but it has plasticity. Ooh, big science words in here. Here's another one. Plasticity is the condition of a solid that flows, that allows it to flow like dough or putty. So if you think about dough like bread dough or Play-Doh, if I hold it up here, it will begin to drop out of my hand very slowly. It's a solid, it's not a liquid, but it has plasticity. It has the ability to move. Tectonic plates interact at plate boundaries. Tectonic plates are constantly moving. At different times, some plates move faster than others. However, even the fastest plates move only tens of centimeters every year. Tectonic plate boundaries are places where the edges of two or more plates interact with each other. All right, time to get back the highlighter. This time I want you to highlight the word plasticity. Remember, plasticity is the ability to move even if it's a solid. So like Play-Doh, I can mash it. It's a solid, it's not a liquid, but I can smash it and it will move. Tectonic, those are the plates that we're studying, and tectonic plate boundaries are the places where the edges of two or more plates meet. Okay, so let's think about this. Because Earth's plates are moving at different rates and in different directions, there are different kind of boundaries. So these places where two plates meet.